Testing, 1, 2, 3. Of course, I have no idea if the sync is correctly set up. Let me see. This is a test, 1, 2, 3, 4, 5. Well, it's not perfect, but it's not terrible. That's the worst part about using a different audio device from my webcam is they have different latencies. When you use the webcam with the webcam microphone, it automatically does the right thing. Mic is kind of low volume. Well, sorry. Oh wait, is there a thing here? I don't know what this. Testing, 1, 2, 3. Yeah, you know. Hello, hello. It's pretty weird. Like there's a. When I speak, it doesn't really seem to be that much higher than the noise floor on the mic. Levels. Oh, let's put that at 100. How's that? Is that louder? Oh wait, that's on the webcam. That's not even what I'm using. Levels. That's at 100. Well, I don't know, people. It's better. All right, well, that's good. Maybe it's simple. You know, I'm not really convinced. Let's do an A/B test. All right. So this is the Audio Technica USB microphone right now, and then in a second I'm going to switch to the webcam, and you can tell me which one's better. Okay, this is the webcam. It's definitely louder. Let me turn that down. So, is this higher quality, lower quality, same quality? Probably it's delayed, but that's because I have to go toggle the delay setting here. But yeah. Webcam is really bad. All right, we'll use the webcam because everybody likes that. All right, we're back on the USB mic. It's so weird that the webcam is bad. Maybe it's just bad in this somewhat noisy environment. This office is like right off the street, and so it gets a lot of background noise. Maybe there's something misconfigured in that webcam. Maybe I dropped it on the floor. I don't know, to actually figure out if there's a boost happening on the camera mic, it would like take a long time. I'm not inclined to bother figuring that out. Yeah, definitely. If you're seeing problems in the Witness after the update, definitely post on Steam. We want to know about that stuff. For sure. Just post some screenshots or let us know where to stand and where to look. Yeah, I can't, like, I definitely could set up noise dampening panels. The thing is, we're going to move office again soon, so investing time into making this quieter is not really a good use of time. I should really make an interactive timer. I like messing around with it by hand. That way I can delay the starting time by as much as I want. Have I ever written a neural network? Yes. Where's my office located? San Francisco. That's right, I'm never late if the stream starts later than I say it does. Or if I say it starts, well, whatever. You know what I'm saying. Share my thoughts on the very recent security flaws found in nearly all modern CPUs. Yeah, I mean, it's just that things are way too complicated, and this should surprise nobody. And for now, they're just going to Band-Aid over these problems, but then people are just going to find more problems. It would be very good for everybody if we just stripped everything down and started over. But nobody really wants to do that. I actually have plants in front of my desk, but they're not really thick enough and whatever. How do I think the level of programmers in studios like Naughty Dog compares to the elite in the indie world, like you, for example? Not in terms of quality, but what are the differences in programming? Okay, in general, so let me take myself out of the discussion for a second, because I am not typical. If you talk about indie programmers, most of them are much younger than me and grew up in a very different environment. And I don't think that most indie game developers are good programmers, just as a blanket statement. And it's because they grew up in environments where they didn't have to be good programmers and they could like use Unity and whatever, right? So your average AAA game programmer is a much better programmer than your average indie game programmer. That's just how it is. Because the AAA people at least went into environments where they had to make high-powered stuff happen. So I'm different from most indies because I started a game company in the 90s at the absolute hardest time to start a game company, and it was just took a great deal of very difficult work just to get the image on the screen in the first place. And it was a very formative time. I had to work very hard to make anything happen back then. It was not like today at all. And in doing that, you come to understand things very thoroughly, and you just get to practice a lot. I don't know anything about RISC-V. Takeshi CS, if you're going to make name puns, I'm going to ban you from the channel. I've been hearing that stuff since I was in like the 2nd grade. Let me see if I can modulate my amount of overhead nuttiness. See if that helps at all. No, I still got a big shiny spot right there. Can't really do a lot about that. Without turning off all overhead lights, what if I switch? Let's see how that looks. It's a little less extreme. It's not great, but we'll go with it. We'll go with it. I'm going to go tweet that we are starting. Yeah, I program in coffee shops a lot, and so, etc. I have no advice to somebody starting their first indie game project except that it's going to be a lot of work, and you just have to do your best to get a lot of work done. A lot of work done. No, my opinions on Go and Rust have not changed. They're basically the same languages as they were in 2014 when I made that video. Am I going to bring features from Lerp into the new language? No. Are there any recent multiplayer games besides PUBG that I recommend? None are coming to mind. What font is that? It is Carmina. It is the same font used in Braid in The Witness. It's Carmina Bold, actually. How much time do I spend looking for interesting indie games to fund? Not as much as I should. I have a big backlog of games. So I need to get through them, but I also have a giant backlog of work emails, like 40 of them that I need to get through. So life is not easy for me right now. Have I considered some kind of powerful control flow syntax that provides the strengths of Ruby blocks for enumeration, loops, and other abstractions? Blocks are the thing that the creator of Ruby is most proud of, and one of the things that programmers love about the language. I don't know what Ruby blocks are. I don't really have a problem with control flow as it is. I don't feel like that's anything that needs any more work, but if you want to send me a link, I could take a look. What do I think about functional programming in general? It's a good research topic, but I wouldn't use it to make games in. Have you thought about making a JavaScript script? Yeah. Do I give advice to people I fund? I try to, but almost nobody ever listens. Do I have any ideas on where I would start if you were to try to get that bananas world towards sanity? I don't know. It's so insane now. I literally have no idea. Like, I had a dream the other day that I was like going to make a web browser or something from scratch, like in this language using these libraries. And it seemed plausible in the dream because, you know, just in the old days, like I actually made a simple web browser in the old days, and it was pretty straightforward. You just like parse some HTML and do some rendering and stuff. But now, like, you need like JavaScript and cookies and SSL to even get off the ground and display anybody's website. And that's just completely insane, all of that put together right there. So I think step one to making it less stupid is make sure WebAssembly gets adopted and becomes the standard things that browsers run so that they don't run JavaScript anymore. Work on a new server that actually is efficient and serves pages in a way that doesn't consume all the world's computational resources to do trivial things. Those are the two ideas off the top of my head, but I don't spend much time in the web world, so I couldn't tell you. All right, I'm going to stop answering questions. I'm going to give myself like a 1-minute break, and then we will start. What is wrong with the camera position right now? Is it angled wrong, or? I mean, I keep leaning off to the side, but that is something I will not do during the presentation. Okay, yeah. If I'm actually sitting in front of the keyboard, it's in the right place. It's just I keep leaning over here to like look at chat and stuff. All right. Oh, I see. guess we'll begin. We'll begin. Hi, everybody. Thanks for coming by. And it's time to do a little progress report here in January 2018. I don't tend to do progress reports, but it's been a little while since we were regularly doing demos. And so I thought I'd spend a little bit of time explaining why that is, and then spend a little bit of time explaining what the roadmap is for the near future, and then do a demo of some little features that have been implemented lately. So yeah, I haven't really done very many demos in the past months. I think I did one maybe a couple of months ago, and it wasn't a particularly large demo. I've done a number of compiler work streams, not the official demos, but just the, hey, I'm hanging out programming. And I may start doing some of those again in the future. But why not so many demos when they were coming along at a pretty good clip before? And the reason is just that we've shifted into a different mode of development. We're starting to think very concretely about the fact that we want to have outside people using this language pretty soon. And in order to do that, the development phase of the language, or the experimentation phase, involves trying ideas out and making things happen. And often what happens is, in the process of doing that, you incur some technical debt. Like, I'm going to try implementing this in a certain way, or I just need it to work for particular cases. But then once you decide that the language semantics or syntax or something are really going to be that way, then there's some going back and backfilling to make things robust that needs to happen. So, what have we been doing? Well, I don't remember my commands here. Here we go. Well, we've been doing a bunch of testing and fixing bugs and re-architecting internals of the compiler. We have a regression test suite now that Avner's been working on, so I can run this thing. We didn't used to be this organized, but some of you may have seen this in some of my more informal streams, but we have this test suite that tests for regressions and makes sure that various features work. This is, of course, a basic thing that everybody should have who's like shipping a product that they expect people to use, but we didn't have an official one. The most official thing that I used to do was just compile Sokoban all the time and make sure that works. That's a relatively complex program, but it doesn't, permutationally go and use different features in very specific ways. And that's what this test suite is supposed to be for. And so we've got that now. And so, creating that test suite and then fixing all the bugs that came up, changing internals of the compiler so that they would be simpler and easier to understand and handle more cases more generally. All of that that falls under the category of improving robustness really has taken a lot of time. And I wanted to prioritize this kind of thing over implementing new features because, again, once there's enough technical debt, if you keep implementing features on top of that, your foundation just gets more and more rickety. And it takes you further and further away from what you need if your goal is to give it to people out in the world and have them use it and have them not have a bad time like they would in a typical open source project. There's been a couple other things that took some time, like, I spent about 2 solid months helping ship the Witness iOS. It was probably more than that total, but there were 2 months during which I worked on almost nothing else. And then, of course, I had a little bit of vacation. So anyway, that's why there hasn't been such a big density of demos lately. The most common question that I get, nobody will be surprised by this, is when is the release of the compiler? When can I get my hands on it? And all that sort of thing. Up till now, I've always said, well, when it's done. But like I said, we're thinking very concretely about rolling forward and making a release an actual reality. So what I'm going to say today is that we are aiming for a small closed group release in about 3 months. Will take longer than that if necessary. Like if we're 2 months from now and we don't quite feel ready, we'll push it back a little bit more. But this is our goal right now. closed group means it's just people that I invite, that I probably already know or have had contact with. And small means probably 10 people or fewer, which is not very many people. But the goal is just to sanity check what we have, make sure there's nothing obviously stupid. If there's things that are going to massively waste people's time, we identify those and nail them down while they're not wasting very many people's time, right? And then once this goes successfully, or depending on how successful that goes, we'll pace out further invites and grow the circle of people who have access to this over time. So let me talk then about, so if there's roughly a 3-month schedule, what am I going to be doing over these next 3 months, or what are all of us working on the compiler going to be doing? The biggest thing is an overhaul of the library system, or not even so much of an overhaul as making it more of a solid thing. You know, the library system that is in right now is essentially the minimal thing that I needed in order to do application programming, but it can and should be better. And there's enough issues to talk about that I'm going to dedicate a whole stream to this. I want to do this next week sometime. I haven't decided exactly when, but I'll probably announce it tomorrow, where I'm going to have a stream that's mostly just a discussion stream where we talk about what are what properties should a good library system have in this language. And some of it will be me saying what my ideas are and what my plans are, but some of it I just seriously don't know at this time what the right answer is. And so, you know, part of that is going to be to stoke some discussion and see if people have ideas that can affect the direction of this before we go. There's something really loud happening in my office somewhere, and I'm wondering if I should go try to track it down, but let's say no for now. Smaller feature, but that should happen before anyone gets their hand on the compiler, is better struct and array literals. Both of those are kind of phoned in right now. One medium to large size feature that I've been thinking of for a while is to have some kind of macro form. This would not be like C or C++ preprocessor macros. This would be more like Lisp macros, but it would be a way of tying into the kinds of program introspection that you've already seen. So this wouldn't be a totally separate system. It would be a way of accessing some of the things that you've already seen from elsewhere in the program as opposed to in a meta program, right? And one thing that I think is very specifically important is the ability to have a macro that looks like a procedure call, but that somehow kicks off a run directive that creates arbitrary compile time computation. Because this would be very powerful, and there's not really a way to do it yet. The only way to have a run happen, I think, actually it's a little bit not true, but most of the ways to have a run happen is for the user to explicitly say run, which is fine if you want to be clear about what's happening, but I think it's much more powerful to let it happen behind the scenes. And so we will see about that. Now, of course, run directives are not totally cheap. You kick off a running bytecode thread, so if you set up a program that runs 1 million of these, you're going to pay for it in compile time. But you'll still probably compile a lot faster than C++, so whatever. Of course, much more hardening. I want to do many more test cases. I want to write more exotic programs that do weirder things. I want to do some fuzzing maybe before we put this out to the world. That said, by the time we release to this initial 10-person group, there are going to be still probably some things that we know that the compiler doesn't handle or that it doesn't do correctly, and we'll just let people know at that time what those things are as best as we know. But of course, part of what will be happening is discovery of the problems. Continuing this list, I want to work a bunch on error messages, because there are some cases when error messages could be a lot more helpful than they are, especially when it comes to polymorphism and figuring out exactly what the problem is when you're trying to call a polymorphic function and it's not exactly matching. Of course, we're better than C++ at that now, but we can be much better than we are, and you can save a lot of programmer time. Like, one reason people hate generics is because it's so hard to figure out why they're not doing what you thought. And so if we can fix that, it's yet another one of the things that'll make them much nicer and much more usable. And then there's just a grab bag of really small features or finishing things out that needs to happen. So for example, we have this array bounds check feature, and I'm pretty sure if you compile using the x64 backend, we just don't insert array bounds checks because I never got around to it. You know, we have notes on structs and stuff, and right now they're just strings, and we can make those structured and so forth. So we'll see how many of these we get to. I'm not going to hold back the release for smaller things like this. If I do hold back the release, it will be more like stability kinds of issues. We're not going to wait on bigger features, though. So there are a couple of bigger features that I've alluded to over time that are not yet implemented, and we're not going to hold back the initial small circle release on those, in part because the people's feedback can help us shape these features a little bit better. And we're just going to have enough work to do just shipping and enhancing the current features. So if that 3-month date slips, again, it'll be because of basic compiler robustness or something important like that. It won't be because we're trying to shoehorn in something giant that we haven't done yet. There's one other kind of thing that may hold us back a little bit, and that's like legal issues. Like I want to make sure there's proper, good copyright protection on the source that'll prevent someone like Microsoft from doing something evil with it. Okay, so that is it for the status report. I could do maybe a couple quick questions on what we said there, and then we'll move on to the demo part. You already can call existing C libraries. That's already a thing. Oh, one feature we need to make happen is actually being able to build static and dynamic libraries as output targets. Like right now, you only can build executables, but that's not hard. Is there a schedule for the documentation? Will it be complete at general release? You know, we're just going to have rolling improvement on documentation. Right now, there's almost none. By the time we go to that initial 10-person release, we'll definitely have, you know, some programs that we give out, some of them small and some of them large, and we'll probably have a README that tells you a lot of things. By the time we do a general release, I want to have a series of programs that walks you up from something simple like Hello World up to something complex that draws graphics and stuff, and that tours many of the language features. So that'll be more like annotated programs. I think that's better than just having a giant, you know, 500-page README before you use this language. I don't think that's very interesting, but that's going to be developed. Someone says, feels like macros will take 6 months. I don't think so, but if it does, we won't hold back the release for it. Still using the Microsoft linker? Yes. You said once you wanted inline assembly, will it not be included? That will not be included in the initial small release. We may work toward that later on. Or, yeah, I don't know. I mean, inline assembly is just big because you have to write an assembler, and x64 assembly at this point is just huge and gnarly, right? And so it's just not trivial, and there are probably better places to focus the effort in the near term. But yes, in the long term, we still plan to have inline assembler, yes. No, we're not going to self-host the compiler anytime soon. Yes, this slideshow is in the slideshow program that I wrote some months ago. Is the compiler going to remain a compile all source files at once kind of thing, or are you planning on adding in the more traditional scheme of generating object files or translation units per source file? No, I think translation unit per source file is a terrible idea. We only do things that way for historical reasons. And if you do that, then you essentially destroy many of the language features that make this language good. You know, if you only have access to object file from a procedure, then you can't make that procedure polymorphic all of a sudden, or you know, do some of the other interesting things we can do. So as far as I'm concerned, single compilation unit is the model forever for this language. Of course, if you want to, you know, you can make build targets that are libraries and build your program as 4 libraries and then link them in the final step. Like, nobody's stopping you from doing that, but it won't be the default. Yes, that email address is still valid. Will the initial distribution include people in industries other than game dev? Maybe. It'll be just people who I think are serious about wanting to play with it and who are experienced programmers and will have good things to say. I haven't decided who it is yet. Am I going to put the code on GitHub? Not anytime soon, but for the final release, yes. Who will be maintaining it? Probably us. Will you take pull requests for new features? Probably not initially. In the long-term future, yes, but it won't be open contributions for a while. Will there be full class cross-platform support? We already do Windows, Linux, and Mac OS, and we want to do at least one game console as well for the final release. Any chance of releasing the tests and headers before the discussion panel as a sort of documentation? I don't know what you mean by the discussion panel. Oh, the discussion on libraries next week. I don't think that's necessarily that important. I think we can just talk about it at that time. Just because the kind of topics that I'm going to get into is not really what's in the libraries, like what functions are there, but more like how do libraries work? Or modules. Let's say modules, because when you say libraries, people might think like static library or DLL. That's not what I mean. I mean like, hey, what's the standard set of routines that I get to use? Or like what, if there's a graphics library, how do I use it and stuff like that. All right, that's enough questions for now. We can do more questions later or after the stream. So hold on to those. I want to get to the demo because even though this one's hopefully going to be short, sometimes these take a really long time. I don't know why. So let's just run this. It's just a printy demo. It doesn't do anything too crazy. Just going to talk about the features I've been doing lately. The first one, which is normally it's trivial enough that I wouldn't demo something like this, but it's for people who have been following along, I want to make sure they don't get confused by stuff they see next. So the first thing I'm going to say is that the syntax for enums has changed from what you've seen in previous streams. There used to be a C-inspired syntax where you put commas between the items, and there was like 1 colon, and now it's just this. It looks like, hey, name, colon, colon, value, or just name, semicolon. And the reason for the name, colon, colon, value is just because there's no reason you shouldn't be able to paste stuff into and out of enums. So if you were being lazy for a while, and you didn't make an enum, and you just had a bunch of constant declarations at top level like this, and then one day you decided to make this an enum, you should just be able to say whatever is an enum, and just do that and be done with it, right? You shouldn't have to like go in there and change the commas to semicolons and the 1 to 2 colons, and that's just a pain in the butt, and there's no reason for it, right? So the syntax is now that those just look exactly like constant declarations. And then if you're using the thing where the enum automatically increments the value, then you just don't put the value, right? And that works still just like C does all other ways. It's just, of course, the syntax is different. So if we come over here, so I say here I'm using fruit, which is this enum, and I say x is papaya plus 1. This is an autocast because normally this would give you an error. Adding 1 to an enum, 1 is not of an enum type, so it would complain about that. But you just say whatever, just make it work with autocast. And so papaya plus 1 gives me mango, of course, and that's what I have here. Now recall our print statement prints out enums by name. That's going to be important in the next section that we look at. Right? If I want this to be an integer, I can cast it explicitly to an integer in the print statement like I do down here. So I say, what's Nolly healing fruit? And I cast Nolly healing fruit to an int so that I get the integer instead of the name. And that's going to be grape. It's going to be the next one after grapefruit, which is 86, right? So this is the way that enums have worked the whole time. It's just a different syntax, but it's just like C where it'll auto increment. And if you skip forward, it'll auto increment from there. Okay, so the new feature is that now we have an enum specifically for flags. So instead of saying enum here, because flags are a thing that you put in enums all the time, right? And in C++, it's really annoying. You have to like auto designate the values or whatever. So here, we have a new thing where you say enum flags, and again, you can specify the base type of the enum, just like whatever. And here, I've just let the compiler auto-pick all of the values for these. I'm using the flags, and then I'm going to print out the first 4 here, and I'm casting them to int. So instead of seeing the names, we see the int values, and we see here they're 1, 2, 4, and 8. So when you have an enum flags, the way of picking the next value is just by doubling the previous value, right? Powers of 2, so that you can flag them together. Now, one good thing about this is that the print statement, or the print function that you can use, understands enum flags and can print them out in a useful way. So here I'm declaring a flag, lowercase flags of type uppercase flags. That gets the default value, so it's going to start at 0. So we see here 0. Let me get both of these at the same time, actually. Side by side. So then this was 0, right? So that's 0, that's 0. And then I OR FC, whatever the value of FC is, and then I print it, and it says flags is FC. And then I OR FA, and I print it, and now it says flags is FA or FC, right? I OR in FD, and I print it, and now it says it's FA or FC or FD. Now notice that the order here is different from the order in which I'm ORing them, but that's just because, print doesn't know what order I ORed them. It just knows it's a number. Down here, I ORed casting to type flags, this arbitrary integer that goes way beyond what we defined, right? And I print it, and it says, well, it's FA, FC, FD, and then FG and H, and then also this number that was not included in any of the previous flag values, but we need to say it, right? So that is very useful and very nice. It makes flags much less annoying than they are in many languages. Now, just like in the regular enum case, you can define these values at any time. So here we've got these other flags. GA is going to be 1. By the way, we do start at 1 instead of 0, because you don't, for a regular enum, you start at 0, but for a flag, you don't really want a flag 0. That's just confusing because it won't work. All right. So here we say GA, GB, GC, GD. That's going to be 1, 2, 4, 8. And then here we've jumped to OX1000. So then you can guess what GF, GG, and GH are going to be probably. So here I print GD, GE, and GF, and they're 8, right? Because that's 1, 2, 4, 8. And then I skip to this, and it's like, oh, that's 4096. And then the next one is, of course, 8192. So that totally works as you would expect. Now, in this list, you can put arbitrary numbers. Like you could put a bunch of numbers ORed together if you want. But you could also make a mistake if you're doing that. And so what happens if the compiler, like if I stick my grapefruit as 85 in here, and the compiler tries to auto-increment that for the next flag, well, it'll complain, right? It'll say, hey, the declaration is trying to use the next value in an enum flag sequence, but the previous value is not a single flag, it is OX55, right, or integer 85. Maybe I should print this in integer if you gave it or in decimal if you gave it a decimal, whatever. But actually, I believe, I haven't actually tested this, but it should work if I do it there. Yeah, because it doesn't need to auto-increment this. So it's like, that's not a single flag, but it's fine. You can do that if you want. It would be nice if enum flags added a flags.none. Well, you can use literal 0 for flags.none, right? Like there's no, if you want the name none, you can put that there, but the literal 0, so here when I said numbers don't cast to flags automatically, you have to cast it. That's true unless it's 0. If it's 0, then it's automatically any enum. Okay, so that's that. Next part of the demo, union test. So prior to today, we didn't have unions, right? I demoed a long time ago this thing called the place directive that tells you where in a struct you want to co-locate something in memory. So if I had the struct A, and it's got a type tag at the beginning that like maybe we're using to know what's inside A, like which members. Because all these members are going to land on top of each other in memory, just like a union from C, then we need to know which ones are valid and which ones aren't. So here I've made this thing of type void, which is legal here. It's not legal in C, I don't think. It certainly didn't used to be, and I think it still isn't. But we can use this to say this is of size 0, and we can just use it to say, well, just put somebody there at that place. And we've got a radius that's a float, an account that's a signed 32-bit number, and a name that's a string, and whichever one of those we're using all depends on what's here. And then say, okay, we're done with all that. So after the name, put this position and angle, right? The problem with this is very useful in some cases, and we can talk in a little bit about why that's useful. But for cases like this, it's actually dangerous and error prone. And the reason is the following. Suppose I just decided to reorder my members for readability. All I did was I took this name and I moved it up to be the first one, right? So now the string is first and the float, whoops, I changed this from radius to distortion, but whatever, there's a float, let's change that. There's a float and S32, right? I just moved the name up to the top. The problem is that the name is bigger than the other members, so by the time I'm done with this count, I'm still inside the name, and now these later members that aren't supposed to be part of the union overlap with the name. So if I print size of A and size of B, they come out different. So size of A is 36, but size of B is 24 because things are overlapping when I didn't want them to, right? And the reason that's happening, again, is just because this guy is bigger than the other guys. But it's not obvious that reordering this is dangerous. And so for that reason, we now also support C-style unions, right? I can do it like this, where I'm, say, using U, colon, whatever, or it can be an anonymous union. And so in this case, it's also much more readable. I've just put these things, actually, we don't need this here anymore. I've just put these things all in one group. And now you don't worry about it, and it goes to the bottom. So now size of C is the same as size of A. It's 36, even though I moved name up to the top, right? So I believe we're going to keep, oh, this comment is, let's delete this comment. That was some old code that comment was referring to. Anyway, so I believe that we will keep both facilities. We may add some features to the place directive to make it more useful in more situations. The place directive is useful when you want to maybe pack a type tag or some other things in a way that defies conservative, weird alignment that the compiler might do. And a union is something that you might want to use when you're totally fine with padding this out to whatever alignment that you want. We'll see how that shakes out. Okay, so like I said, that union was anonymous. Unions don't have to be anonymous. You know, I can just the way I could name a struct type before, I can name a union type. A union is only a struct where all the guys land at the same place in memory, right? So, so here I've got a union called stuff, and I'm saying size of stuff is whatever, and where are we? It's 16, and the reason it's only 16 is because a string is 16, and these are all smaller than that, but we pad out to the size of the biggest member, right? All right, so now I'm going to set the name to Sailor, right? And I print stuff.name just to prove that the union works. So I print stuff.name, and it says stuff.name is Sailor. And I say stuff.c, and it's 6. And the reason it's 6 is because that's the length of Sailor, because the name, the first value in name is the length of the name, and the second value is the pointer to the name. And the length, since this is a little endian machine, it's an 8-byte integer, but the lower 4 bytes is the lower 4 bytes of the length, and so this signed 32-bit value captures that whole thing because it's only 6, right? That fits in 1 byte, much less 4 bytes. So, you know, that's just showing that we're correctly reading the value out of the union. Unlike some other languages you could name, unions can have constructors. I put constructed thing at global scope instead of right here because I wanted to use it again later. in another example. But so here we have this thing called constructed thing. It's got some members, but it's also got a constructor that says, well, map A to float32 infinity, right? This, if you haven't seen the quick lambdas, this is just a polymorphic routine where the type gets inferred as needed. It's still strongly typed, just like anything in C or C++. Because this is a constructor, it just, the type of X becomes pointer to constructed thing, right? So then we're just saying that A is float32 infinity, right? So now, so we instantiate this, we take the size, and then we're going to print A and we're going to print C. And now C overlaps with A again, and they're the same size, so what do we see? Well, we say the size of constructed thing is 8. That's because a float64 is 8 bytes. Thing.A is inf. That's how we print out infinity. And thing.C is, well, if you know IEEE 734 floating point representation, then you recognize this number. It's the hex representation of positive infinity, right? So that is that, union with constructor. You can declare a union in any scope, including a procedure or a top level. Again, that's not a big surprise. In C++, you can do that. In C, even, I think you can do that now. I don't know, probably. But you know, here I'm just saying union, elephant, pelican, and so the result is these are both local variables of this procedure that overlap with each other, right? So I could say, I can do that same length trick, except I'm doing it with 64 bits now, but same thing. So elephant says, unfortunately, there's a radio connected to my brain, and then pelican is going to be the length of that string, which is 53. And then same with enums. I can make an anonymous enum, and if I do that, then I'm just using it, and all these values are pulled into local scope. So without explicitly saying using or anything, I can just say that and say CC is whatever, 2. So some of this is just like in C or C++. Some of it is not like in C or C++. All of it is relatively new over earlier versions of the language, so I just wanted to hit all that. Okay. Next, anonymous structs. This is a syntactic expansion of the language. You didn't used to be able to do this following thing. You used to have to name a struct type. Now I can say, here's some variable S, and what type is it? Well, it's some type struct that has a float called F. I didn't name the struct type, right? And that works now. So I can say, well, what's the size of S, and what's the type of it? Well, it's 4, because it's only got a float. And the type of it is, well, anonymous struct, because the print statement doesn't really know. Actually, the print statement probably can tell you what file and line this was defined in. So if we don't think it's too verbose, we might put that in there. Same with an enum. So I'm saying I can say E is some enum with this stuff, and so that it'll be the default value, which is 0, which is the first member. So it's alpha, and then I set it to gamma, and then there. Right? What do I want to say about that? This is not really anything fancy. This is actually how enums and structs worked in original C. Like in C, you didn't used to be able to name these at all within the construct without adding a type def around it. But for the way that I program, I usually use name, struct, and enums, but it felt like the language needed to be able to handle them anonymously, and so that's fine. Now, here, this is relatively mundane so far, but it starts getting a little bit more cool when you remember that types in this language are first-class values as they are in functional languages, even though this is a fully compiled, statically typed language. So you can create and pass anonymous struct and enum types by value, and you don't have to give them names, right? So first, I'm just going to make this procedure F. It's polymorphic. It takes a variable called T of some type, and so the argument is a type. We don't know what type it is. We print what the type is, and then I get the type info. If it's an enum type, then I print enum, and otherwise I print struct. And those, because I didn't want this code to be really long, I put those out of line, but we can jump to them at the end of the file. they just go over the members and print all the members, right? And this is just using the type info introspection system that you probably have seen many times before if you follow these. If you don't, there's a presentation on YouTube that talks about how they work in great detail. Okay, so I'm going to call f on the type constructed thing, right? That is, remember, that's this guy that had this constructor. And when I do that, it's going to say, well, the type is constructed thing. It's got a member called A, a member called B, and a member called C. We're not printing the values of the members because we don't have an instance. We don't have any values for those members. We're just printing the type, or we could print the types of the members. Let me do that for struct. Oh, no, let's not do that because I don't remember. We can, I just don't remember what the routine is in print. Let me see. There's print type to builder. I'm not going to do it right now. Just because it's probably, where am I? It's probably, yeah, let's not do it right now. Do it later. We'll do it in the Q&A if we care and if I'm not tired. The reason is just if you print a type, then that's fine. But if you have a pointer to a type info, that's a different thing. And so I need to call a procedure to do that. And I have a procedure to put that into a builder, but I don't necessarily have one to do it here. And if this print sees a type info, it'll print the contents of the struct type info and not the actual type. Like the default behavior is not exactly what we want. Okay. Anyway, so why is that cool? Well, instead of just passing a name type, I can just make an arbitrary type right here. So here I'm going to call f on some new struct type. And what is it? Well, I don't know. It's got a position that's got a vector 2. It's got a bitmap name that's a string. And it's got a radius that's a float. And that just works. So t is some anonymous struct. It's got a position, bitmap name, and radius. And then, of course, instead of using this form of the declarations, I can use the form that gives things default values. Again, even though this has numbers, this is still not an instance. This is a type that if you instantiated it, would have an instance with these values in it, right? But the type doesn't have those values in it. It just has these members of these types, right? Now again, this could look confusing. Well, let's go here again, right? So again, it's an anonymous struct with members x, y, and name. So this really has no analog in C or C++. I mean, maybe in C++ you can do some very painful template things, but here it's built into the language semantics. So this is just fundamental and it just works. So that's very nice. Again, that also works with enums. So I've got this enum with different values, and we print all the items in the enum. Now, why would you want to do that? Well, you know, we've demoed before all of these you know, ways that we can manufacture new types based on old types using, you know, modify procedures and dynamic specialize and all that stuff. Well, I just want to show that you can pass this to something. I don't want to go, because it's off topic for this demo, I don't want to go rehash all that kind of type manufacturing thing. You can go back and watch those demos on YouTube. But just to show the basic idea, like I could have this instantiate and print routine that prints the type just like before, but then I can instantiate a value of that type. And the reason I can do this, even though it's a compile time, fully type checked, statically checked language, is that this argument, this $, means that we insist on knowing this argument lexically, right? So therefore, we can recompile this routine for any instance, any different value of this parameter, right? So, so we can instantiate this thing called value, which is of whatever type the type is, and then we can print it out, right? And so we call instantiate and print just on this struct type. It'll again print the type, and then that'll say anonymous struct. And then we'll instantiate a value, and we'll print the value, and the value will have initialized all the fields to all these values, and so we'll see all that, right? So here we go. T is anonymous struct, the value is x is 1, y is 3, name is hello. So that's all cool. And I expect this kind of thing to be very useful when it comes to just heavy use of generic programming or polymorphism or template metaprogramming or whatever your favorite name is for that kind of programming. Okay, now best convenient feature for last, something that people have wanted forever in C and C++. First, we're gonna just look at these declarations for a second. Oh, someone asked if you mentioned the same anonymous struct twice, are they the same struct? No. There is no duck typing between things unless you make that happen yourself. So by default, any two struct descriptions are different types, even if they look the same. Can you pass a value of type struct x float to a function expecting an argument of type struct x float? No, because those are different types, actually. Anyway, okay. Last feature, and then we'll go to Q&A. So I've made here a simple system like you might have in a game where I've got some types of entities, right? Uninitialized, so I know if I forget to set the entity type. And then we have inanimate objects, we have doors, we have humans, and we have dogs. And whatever this game is or program or simulation that I'm talking about, the entity type is a 1-byte U8 thing. And then we're going to define what's our base class, but we don't really have classes, but it's a struct, right? And the type is going to be uninitialized, right? Which then automatically makes it an entity type, right? That's the type of it. But we've elided the type and let type inference do that. It's got a position that's a vector 2. It's got like a bounding, center, and radius like you might have in a game. It's got a mesh name. And then we've got some arbitrary array of 3 values that are float, right? So that's all that is. Something like you might have in a game. And then we've got a door and a human. And both of those have entity as their first field, and they're using that, right? So they're both compatible with type entity or whatever. They're, in C++, you would say they are subclasses of entity, except of course that we don't do vtables or any of that nonsense. And in fact, you can't shadow methods, or you can't shadow any kind of variable name automatically using this. Okay, so you may note some new things down here. So I'm saying a door is an entity, but here I'm saying, oh, but type equals door, right? But type is up here, right? Well, what's going on is that I can, any declaration that has a value that's constant, that doesn't require code that doesn't require code to run in order to declare what the value is, you can, sort of patch that in and say, well, this has an entity here, but the type field has the value door, right? And the mesh name has the value door default, and the bounding radius has 1. And by the way, buffer values, this is our crufty syntax for array literals that we're probably going to change. But we'll set buffer values to 1, 2, 3, right? So we can do all of this, and it doesn't require any code to run in order to happen. It's the same as if you had just pasted all these things down here and changed the values, which is something I've wanted to do in C or C++ for really a long time. So that is cool. And then in human, I have maybe some different, well, let's look at the printout to make sure that works. So here's door. It's got a base, which is an entity, and you notice that the type on entity is changed, right? And the bounding radius is 1, and the mesh name is door default. And the buffer values here, print only goes 1 level deep on arrays, so it didn't print these, but we print them out manually here, and they're 1, 2, 3. And then again, for human, we did the same thing, except we went as far as saying, hey, position.x is 5 and position.y is -5. That works, right? So it doesn't just have to be the name. You can sub-reference stuff. And in fact, you can subscript arrays and all this, right? For this to work, we have to have some equivalent of const expressions, like in C++. Like it has to be language semantically guaranteed that this is a constant that you can refer to without running code, right? So all this stuff, I don't think we ever demoed that, but you might have caught it on an informal stream before, that we implemented all this const expr stuff. So this gets reduced to 2 before, really before code generation even sees it, right? This gets reduced at the tree level. But then you can also, so the whole point of this is to do lightweight things without having to use a constructor, because constructors are annoying and stupid. But if you want to, you can still use a constructor. So here we have a constructor where we set the mesh name to human with a random number afterward. And so note that both of these things happen. So the position gets set to 5 - 5, but the mesh name is also human 1. So if you saw the stream where we declare initializer and constructor and all that, these go into the initializer and these go into the constructor. And you'll note we set buffer values to 1, 2, 3, and then we set this to 7. This is a little bit of a conflict right here because we're doing two things, and strictly speaking, if you thought this was totally declarative, then these are saying to do two different things, because this says to set the third value to 3 and this says to set it to 7. But for now, I'm deciding we just execute these in order from top to bottom, and whatever you end up with is what you end up with. And we'll see if that's bad or good, but it seems okay to me for right now. Now the one last thing that's a little bit maybe interesting to note is that door and human here are declared in 2 different places, which means it's just a test that this member setting works in 2 different contexts, right? This is at global scope, which means these values are set in the program image. So the compiler like pokes them into the global data segment during compilation time, right? Whereas this one, the initialized default values get filled out in code, right? Because the code here says allocate a human on the stack and then make sure all the values are the default values, right? So these 2 things are getting filled in totally different ways, but they both work, right? Okay. Now here I was doing this thing where it's sort of a subclass where you're using a thing, but that doesn't have to be. It can just be any field that's just in the struct can be initialized this way. So like here I have a struct called bounding box, and it's not like a subclass of anything, but it has 2 points, P0 and P1, that are the lower left corner and the upper right corner, right? And here I'm just going to say I want P1 to be at 1, 1. We don't have struct literals yet. It's one of the things. I probably should have put that in on the roadmap of what we want to do before the initial release. But so I just set the members separately here for now. But you see, I declare a bounding box and then I print it, and you see that P1 is at 1, 1. So that's nice. That is everything that I wanted to demo. So I'm going to take a 5-minute break. Then questions. Whoa, my font is too big. Back in a second. I'm not necessarily going to see any questions unless you put @ and my name before them, because sometimes there's just a lot going on in chat and it's hard to see things otherwise. So please do that. I'll be back in a minute. All right. Is some sort of serialization easier with this language? Yes, it is tremendously easier than in C++. I have demoed that on YouTube several times. If you go back, maybe somebody can paste a link to the demos where we do serialization. What code gets generated for setting struct defaults? Is it like a mem copy from an exemplar, or is it just regular assignments? Right now, it is regular assignments, but it doesn't have to be that. You know, like, I think probably the right solution is some heuristic that says, how many assignments are we doing? You know, if it's, if it's like 4 or 5 assignments, just do the assignments. But if it's a lot more, then we mem copy from an exemplar, right? But that's, that's sort of a level of optimization that we're not really worrying about yet. And it's also like, it's kind of easy to do. Oh, there is one exception, right? The exception is if the struct is all 0, then we just, mem set it to 0, right? Or not mem set, but like we just wipe zeros across it. We don't store zeros in all the slots, right? So that's the lowest hanging fruit thing. But yeah, mem copy from an exemplar is definitely an option. That might even be a thing that we let you specify how it happens later on, although we don't have any mechanism for that right now. Will unions have safety and debug modes so that you cannot accidentally use the wrong union value? In Zig, you have a secret field for the tag to provide the safety check, similar to array bounds checking. Oh, you mean like when you set the union, you get one thing, it sets the tag? The thing about that is it'll break because you might, for any programming where you directly access memory, you might just like lay that union or just have some bytes, and especially if you loaded in a serialized file that's just binary data that's full of relative pointers and stuff, you might just return a pointer to a union. It's not going to have that tag in there. You can't change the size of the union in that case because you'll just screw up everybody's code. So no, we don't do that. Someone asked about the difference between constructor and initializer. The initializer is just all the static values that don't require runtime code to happen, right? And the constructor is just an arbitrary procedure that is declared by the user that's Turing complete and may go off and do whatever, right? And so just for cleanliness, we factored those into 2 separate things. So because my intuition is that you may want to use them separately. That might be wrong. I don't know. We'll see how it goes. Are there plans for improving threading parallelism? I have not seen any good ideas for how to do threading better. If anyone has good ideas, let me know, but I haven't seen any, honestly. Aside from, there's some simple things. There's 2 things. One is you can help people know that their threaded code doesn't use variables outside where they're supposed to, which you can already do with a compile time metaprogram, but we might make that easier. And the other thing is maybe adding some mutex help so that you say this variable, you have to be holding this mutex to access this variable, which is fine, except that real high performance threading doesn't use mutexes a lot of the time, so that's only helping beginner threading, right? Please don't say like channels like Go or anything like that, because that's not high performance threaded programming. Can struct literals be type inferred into anonymous structs, sort of like a tuple? I don't know if I want to allow that. Maybe. I mean, there's certainly no technical barrier to doing that. It's just, once you have a lot of that kind of thing floating around and you're relying on the optimizer to get rid of it or something, that's bad. And so I don't want to set a tradition of that kind of thing. Do example of print the type of member of struct when procedure is passed a pointer. Yeah, I could do that. Let me do that real fast, just because I said we could do that during the Q&A. So the whole thing that's going on here is just, I don't quite have exactly the right API here. What I have is this print type to builder. So here's what I can do, is I can say builder is a string builder. Print type to builder it dot type, and then I forget what string builder, we say builder to string. I'm just going to put that in temporary storage so I don't have to free it. And then like that. Whoops, I'm in the wrong console. So where is that? There we go. I should have just done that during the stream, because it really only took a second. It's just I didn't want to stop and think about it, right? So we have an A. Actually, you know what? Instead of saying all this member type, I can just print it in language syntax, right? So I'm just going to say name colon type. It'll be easier to read. There we go. A float 32, B float 64, C has 32, position vector 2, bitmap string. In fact, we can put a semicolon. It'll look a lot like code if we do that. So, you know, like I said, this stuff isn't hard. It's just, it just took an extra second and I didn't want to think about it. Any plans to support runtime polymorphic interfaces, as in Go, for example? Well, I certainly would like the language to be powerful enough that you could implement that if you want at user level, and you know, maybe we'll provide a user level library for that or something. But no, that's too slow for our purposes to want that to be in the core language semantics. Definitely, so someone said it's really refreshing to see a programmer getting excited about programming for once. That is why I started doing this language, is because I got so depressed about using C++. I wanted something better. I wanted to be happy again when programming like I was in the 80s. If you have a function that takes a union, can you pass a variable that has a type included in that union? No. You would have to cast it to the union yourself first. What's the concurrency multi-threading story? The story is that we provide some basic stuff like mutexes and whatever, but like I said, I've never seen, like all these things that people are saying that their language helps with threading, none of them actually work for real programs that have to go fast. What's the syntax for checking flag is set? Same as C? Yeah, it's currently the same as C, although frankly that's not really my favorite part of C syntax, and so we might change that up. Will we make our own linker for the final release? Well, here's the thing. If you're going to link in any external C libraries or libraries written in other languages written by somebody else, and you want to statically link them, as opposed to dynamically linking them, then I don't know if we're going to handle that, because that's like writing a whole linker at that point. I don't know if we would do that, but for the part of your program that's just your program here, that I think we can pretty easily, you know, just link that ourselves, and it'll be tremendously faster than calling the system linker, because those things are terrible. So yeah, that's the plan. Do I have any idea about how much until this gets released? I said that at the start of the stream. Someone who came in late, I guess. Throughout the talk, you used the term type while the keyword was struct. Why is the keyword not type? No, I don't think I used it that way. No, a struct is, when you make a struct, it declares a new type, but there are other types besides struct, right? There's float, there's enum, there's procedure types, right? So making a struct makes a new type, but it makes a struct type. Ignoring JavaScript question. It makes sense to have a C ABI union type, but it also makes sense to have a native union type that does not make guarantees about how big the size is. It's useful to know what the programmer tends to do. Imagine if you had one way to assign a different field to the union and one way to reinterpret the union value. This clarity of intention lets the compiler understand what the programmer wants and then do the optimal correct thing. Super Joe 30. I'm not sure I understand exactly how this helps, so if you maybe wanted to give me an example, then I could think about it. I was thinking about giving a language talk at GDC, but I decided against it. Like giving a talk at the GDC is a pain in the ass. Last time I did it, they ruined my talk. And I've just been mad at them ever since then, for like 6 years or whatever. More than that now. What about an error handling standard or external library metaprogramming function that scans the code for unhandled errors and gives us a warning that tells us which error is reported by the called code or not handled by the calling code? So you mean like exception handling for language errors? I've thought about that, but I think that's maybe a little bit weird enough that it's not going to go in version 1 of the language. We'll see. Like, I think we need some good experience with the feature set we have that's unlike the way everyone else does things before we do things that are too crazy. Will it be possible to compile the WebAssembly? Probably, because we have an LLVM backend and people have LLVM to WebAssembly things. Since types are also values, why would you use the enum value door instead of the type value door? Says James Widman. That's a good question. The reason I did it in this example, so this is generally something, there are two reasons to do that. And this is something that I have unresolved in the long term, but I don't have a good answer for it in the short term, right? So reason number one is the following. I can declare the size of an enum and I can make it as small as I want, right? So these are 1 byte tags, and so I can, fit more stuff. Whereas if you said, type equals door or whatever, you can certainly do that. And in fact, I do that in the Sokoban code base. The problem is that turns into like 8 bytes or 4 bytes. I forget what it is right now. So that's thing number 1. So that's just a little bit of a tweaky optimization. But thing number 2, which is the bigger issue, is that when you do this, you can control serialization. And these numbers will not change unless you explicitly change them, right? Which is also why I'm not letting the enum auto-increment this. And I suspect that letting enum auto-increment is actually going to be considered bad form, and maybe we'll even take it out unless you explicitly say by default with an extra directive that you want to do that. And the reason is because you don't want things accidentally changing if you're going to serialize and deserialize something. Although instead of making auto-increment be bad form, maybe when we serialize, we always write a dictionary of all the enum values and stuff. But that makes the files bigger and it makes reading and writing them slower. So it's unclear what the best choice is there. But anyway, so the problem is if you use a straight up type name someplace like this, that doesn't correspond to an integer necessarily, right? It just corresponds to a string that we then, the number of which might change. So then if you serialize it, you have to serialize and deserialize a string, which is slower. And then you might one day just want to change the name of some type in your program because you're just refactoring the program, and now your serialized thing doesn't work anymore, right? That's a very annoying and mysterious breakage. What the hell happened? And you might not even notice if you didn't try to load some particular file that it doesn't load anymore. So I want to stay away from invisible breakages like that. It's a very good question because obviously the simplest thing to do is just use the type here. But I don't want to start telling people to do things that are going to end up being giant landmines or foot guns in the future. And that is a potential foot gun at some level. For talk about backends, you can watch previous streams. We've talked about that a lot. What are my thoughts on adding a package manager? We're going to talk about that next time in the library stream. What license will we use? It'll be some variant of a very free license. It won't be GPL. It'll be, you know, something like MIT or BSD or whatever the newer versions of those are. It won't be any of this GNU bullshit. Can initializer constants be replaced by run calls to functions that return the proper types? Yes, they can. So for example, you could generate a random number or something. The only thing is, you know, if you're declaring a type here and you generate a random number here, keep in mind that's only going to get generated once, right? It's not going to get generated every time you instantiate the struct. But yes. Will there be closures for GA? I don't know what GA means. Will there be closures? Maybe. It's kind of been my plan to implement closures for a long time. But they're just not very high on the list of things that I actually want, especially once I have all these other very powerful features. We probably will do closures eventually, but I don't exactly know when. Do you have a public email? Let me talk about the email. What was my file called? January progress report. So this is the email where you can contact me. This is not a mailing list. It just goes straight to me. I don't reply to many of the emails that go here just because I have a lot to do, and you know, writing replies to everything takes a long time. But I do read everything that goes here, or most things. Sometimes if somebody gets really excessively spammy, I stop reading what they send, but most reasonable emails to this address I will read. How hard is it to make the compiler work with ARM? Could that be the console architecture you mentioned earlier? I'm thinking about x64 consoles in the beginning just to make it easier. With the LLVM backend, you can certainly target ARM today even. Maybe we should do that as a proof of concept. You know, that won't be the fast backend, but it's, you know, it's not that slow. It's not an order of magnitude slower compilation or anything, so it's fine. Will I ever finish the talk that got cut short at GDC? Probably not. Probably not. Can I just print %struct x:(s32)? Yes, but it'll just say anonymous struct right now. It won't, you know, because you're passing the type, and the type is an anonymous struct. You could certainly make print out all the detail of that anonymous struct, but it doesn't do that by default right now. It's unclear, you know, you don't want your print to recurse infinitely through pointers and everything, because it'll like infinite loop if you pass it certain kinds of things. And so there needs to be a policy about, and also if it's too verbose, then it's just annoying. So there needs to be a policy about what print prints by default, and how much information it gives you, and you know, maybe you could pass it some flags to have it do more information, I don't know. I don't think you can use MIT and at the same time protect against MS taking it over or anything like that. It's a good point. I feel like there are people who have threaded that needle though and done like a license where it's free except prevents, embrace, extend kind of things. So we need to research that and find the right thing, you know. Because we don't want to force you to publish source code in order to use it or anything like that. We don't want any restrictions on commercial or non-commercial use. However, we want to defend against corporate Goliaths, right? So I need to consult with some people about that. It's kind of sad, but that's actually the biggest technical barrier to release, is figuring that out. Is being leet good or bad now? I don't know what that means. An example of how an error handling guarantee could work: if errors are reported using multiple return values, get all the return statements and extract the error values and check if the caller uses those specific values in if statements. Yeah, maybe. I mean, we'll look at that sort of thing later. It's just that's beyond the scope of the initial release for sure. Do programs ship with the C runtime? Right now they do, just because we still use some C things, like we use C's malloc right now, which is bad not just because it requires the C runtime, but also because it's different on every machine. So, you know, I want to instead use TC malloc compiled without a runtime, assuming we can manage that or whatever, right? Our support libraries are currently in C, it's compiled in C and stuff, and it's probably annoying to try to get the C library out of that, but it's not that annoying. So aside from very small connection between the support libraries and the allocator and stuff, I'll just say we have very small dependencies on the C runtime, and we're not growing those dependencies over time, because the plan is to be able to eliminate it eventually. It's just that we're not yet at the stage where we can eliminate it. But it's not like Rust or something where we assume the C runtime is going to be there forever. No. Part of the whole point is that we're simplifying things, and to simplify things, you have to decrease the size of the junk pile, right? Not increase it. That said, on places like Linux or whatever, apparently you can't even start a process without the C runtime, which is absurd, and I hope they factor that apart in the future and fix that. So on Linux, I don't think we can do anything, but on Windows, we definitely can. Besides OpenGL, what other graphics APIs will be supported? I don't know. Out of the box, I don't know, but people will certainly be able to use other people's code that interfaces with anything. On day one, you'll be able to write a simple CTAGS meta program so you can actually navigate the code easily. Yeah, I mean, I might even provide an example of a program that, because I don't even know what the CTAGS format is or whatever, but certainly editor integration is going to be a thing that a lot of people are interested in, especially early on. So I might just write a simple library routine that just outputs the locations of all your identifiers into a dumb text program, text file, where the format is obvious. And then people can just adapt that, just paste that and adapt it to whatever they want. It'll save people time. Are there type declarations for a return type of a function? Yes. If so, do we use type inference? Yes, but we don't infer return types. Plans for Vulkan bindings. I'm not going to do Vulkan bindings, but probably someone will. Are there any lines that can run non-deterministically, like calling two functions in C and adding their results together, which function runs first, etc.? Anything that is non-deterministic. I mean, I guess, so there are certain things that we haven't specified. Like, for example, I believe in C, it is not specified in what order the arguments to a procedure are evaluated. And I assume that we're going to stay the same there. So that's technically non-deterministic, except that the compiler probably will be consistent about that. And certainly it would be consistent over different runs of the program. So, I don't know. I mean, obviously you can write some code that spawns threads and does that, clearly, but apart from that, I don't know. How is the state about metal on macOS? We haven't done any metal bindings, but someone probably will. Was there ever a definitive decision made about how iterators would be arranged? Yeah, iterators are going to use that new macro facility that I talked about. That's actually another reason why I want to do them before the release. So like the style of iterators that I demoed is like a simplified C++ style. It's still way more code than I think it should be just to do a simple iterator. So I'm trying to get that simple and fast. Like if you want to declare an iterator for your data structures and they only in principle have to do a few lines of logic, then the iterator should only be a few lines of code, right? So I think I've mostly worked out the problems in how to do that, and we'll see. Someone is asking, in the instantiate and print example, how does static analysis work when value could have any type? Oh, I tried to explain that during the thing. The point is, this $ in front of t means that you can't call it with an unknown type. So let me do the following thing. If I say f is float, right? So float is a type, so f, let me make it explicit. F is something of type that equals float, right? So that'll compile. Let's just show that that compiles. Oh, wait, redeclaration of f, right. Let's call it some type. Right, so that compiles. So now if I say instantiate and print some type, that won't work. Oh, wait, it does work. What? That's a bug. Okay, that's a bug. I'm putting that on the to-do list. That's not supposed to work. Sometimes we break things. All right. It's not supposed to work because what it's supposed to say is, look, this value has to be known statically at runtime, and this actually isn't, because this could have been assigned to something else. Like what? Where is that? Yeah, well, it worked for some reason. That really shouldn't have worked. Okay. But the way it works is that it did work because it just assumed it knew the value of this was float, but that's not correct. Like, yeah. But the way it works is we just recompile this procedure for any new, for whatever value is, for whatever value of type that is passed in, we recompile this for that type, essentially. But we deduplicate. So if you pass in like float 10 times, we don't compile it 10 times. We only compile it once. Are there going to be changes to the switch statement to make it more consistent with the rest of the language? If I didn't answer an email about that, it's probably because I thought it was too much about syntax, and I don't care about syntax right now. Is it easy to call functions from C libraries? Yes, I do it all the time. There are many demos on YouTube showing that as well. After all the dev time, do you still have a solid visualization of the logic flow of the compiler parts? Yeah, if you mean in my head, yeah. And in fact, it's better now because I've been simplifying the compiler whenever possible, so I understand it better because it's simpler, too. Can you define types that don't accept null or zero? I guess it depends on what you mean by don't accept. You definitely could do a compile time metaprogram that every time you assign to something of that type, you could insert code that checks that the thing that you assigned was not zero. That would be the way, that's the first thing off my head that you could do. As for other things you could do, I'm not sure. There probably are some other things you could do. It depends on like exactly what your end goal is. Have you done any experiments with language translation, like converting to GLSL, HLSL? Not yet, but I have been, I don't know if you've caught any of this, but I do have this program print library that I'm supplying. It's not done yet, but you know, it's 800, 900 lines now. And what this does is it prints from the syntax tree back out to the textual representation of the code. And the goal is to work on this until it fully runs correctly. And then people could use this as a template, right? So then if you want to cross-compile this language into anything else, you know that this code correctly handles all the syntax tree nodes, and then you just change the output, right? So that's the plan. I want to provide people something like this. Any thoughts on optional types and monadic error handling? Monadic error handling doesn't mean anything. Monads, as far as I understand, because you cannot get any functional language person to explain a monad like a regular human being. As far as I can tell, a monad is just a way of creating a statically type-checked abstraction barrier between two parts of your program. That's like all it is. So monadic error checking is like just like everything else that we have. It doesn't make sense. If you mean like algebraic types, no, we're not doing that yet, and we're unlikely to do anything in that direction, except maybe non-nullable pointers as a special case. But even that is very questionable. What about tools? You think about a profile? Yeah, we'll do tons of tools. I talk about those all the time. Of course, tools take time to make. Are templatized atomics going to be part of this? No, they won't be templatized, because I think that's a garbage way to do it. Like, you don't want your atomics to be a template. That's ridiculous. What you want them to be is compiler-level built-ins, right? The reason they're templates in C++ is because C++ just went insane and refuses to add things to the core language that really should be in the core language, right? Saying this integer is atomic should not have to be a template. It should be the compiler knows that that integer is atomic and emits the correct lock instructions around access to it, right? And so that's how we're going to do it. It'll be just something like this. I mean, I haven't thought about it that much, but my thought so far is the following. Let's go to some declaration that's pretty simple. Like here, you can say atomic, right? And atomic. This one's a little hairier because a string is not one value, so I don't know if we'll allow that, but you know, these we would definitely allow, right? So it'll be like that, and it won't cause a template to happen, because that's stupid. Did the compiler see that it has never changed from float, or does the compiler not do that kind of stuff yet? Even if it did that kind of stuff, which it doesn't, we don't do that kind of data flow analysis that earlier in the pipeline. It's not good to allow people to do that because you can't always rely on data flow analysis to know for sure what's happening. And so you end up in a very weird realm of language semantics, right? So the thing that is supposed to work is if you do this, that's declared as a constant and it can never change, and then we're allowed to substitute this. But the bug is, for some reason, we're substituting that. We're treating that as though it's constant, maybe because it's a type. I don't know. Maybe I accidentally broke handling of this in some way. I need to investigate, but it's really, even though it's obvious to any human reader that we know what this is, technically you're not supposed to know what this is because any code inserted in between here could change it. Do we have any tests that check the compiler correctly errors? We don't yet, but we want to eventually because quality of error messages is going to be very important. So, you know, pretty soon, we're still working on the tests that make sure the language semantics work correctly, but eventually we'll expand it to making sure that for all these various cases, the error messages that it generates are intelligible and good. Now, of course, error messages change over time and stuff, so that probably has to be something that humans check. But yeah. How quickly does Sokoban compile? It still compiles under 1 second, but it's taking more time as we add more code and stuff. I want to do another profiling pass soon and get it cut way down. The Microsoft linker is still more than half the compile time, though. Do I expect the speed to remain the same, increase or decrease as the project size increases per line? I think, you know, programs are always super linear. Like they grow, the compile time probably grows slightly more than the number of lines. But I believe we can probably keep that exponent very small, like very, very close to 1. And in fact, yeah, probably 1 for all intents and purposes. But we'll see. I don't know. Is the syntax going to change, or am I going to leave it the way it is? It's going to change. And that's one reason why I don't want to have that many early adopters, because I want to be able to change the syntax without hosing too many people. That said, I do want to supply a way for people to rewrite their programs into the new syntax, which is one of the reasons we're doing that program print library. Can I summarize the design of the parser? It's a parser using regular code. Parsers aren't hard. Remonads, you just mean like stringing together statements that depend on the result of a previous operation succeeded. Of course, you can write if ret equals success after every function call, but that is error prone and tedious. No, I don't agree that that is error prone and tedious. In fact, I think the other way around is error prone. And we can have a long rant about that later, but the least error prone thing is to handle errors explicitly. Because the only person who knows what the right thing is to do when something fails is the person who called that function right there. That's the only person. That's why exception handling in C++ is stupid. That's why this functional language way of stringing lots of things together is bad. Because to handle a failure, you need to know what the failure was. You can't sweep it under the rug and ignore what failed. So I don't think that that's a good tradition. No, I think it's very bad. Will you use SIMD intrinsics? Will there be a less painful way of switching between AOS and SIMD SOA? Yeah, we had some SOA support before. That is deprecated for now, but we'll bring it back eventually. We don't have SIMD intrinsics yet, but we will. We'll have a standard set of SIMD intrinsics for each processor architecture. I do not think that we're going to, well, I don't know. I was assuming that we wouldn't try to make general intrinsics that work most CPUs or everywhere. Like you could imagine having a float 4 that works on ARM and x64 or whatever. But Jeff was telling me that he thought that wouldn't be hard to do correctly, or at least usefully. So we're going to see. Maybe we'll try it and see how it goes. How much slower is compilation when a metaprogram is in the loop? It obviously depends on what your metaprogram does, but for metaprograms that don't do tremendously amounts of work, it's 15 to 20% probably. Any thoughts on filtering which fragments are fed to the metaprogram to keep compile time down? Yeah, I mean, we already have one option for that, which is there is an option to only send the metaprogram messages about declarations that have notes on them, because the point of a note is you want the metaprogram to look at it, right? So you have two modes. You can look at notes only or everything. That may not be good enough. So eventually, I mean, maybe you'll have per file control or something. I don't know. We'll have to see what people want and what makes sense. Do I have any New Year's resolutions? Yes, to release the compiler this year to at least a moderate size of people. Will there be some way for procedures to enforce that the calling code handles their error conditions? There is, way back, when I first implemented multiple return values, so you could find the video by that name on YouTube, there is a hash must directive that says that, for example, if you return a success value, the caller has to at least assign that to something. It can't ignore that value, as you can normally with return values. So then at least it'll be there in the code, and then, you know, like lexically somebody may notice that it's not being used. We don't force you to do anything with that yet, and I don't know what makes sense there. But you could, in a compile time metaprogram, enforce that something happens with that if you wanted to. Will I target any SOCs, i.e. mobile? Yeah, sure. Eventually we want to target everything. It's just, you know, one step at a time. One step at a time. Let me take out my atomic here since the compiler doesn't understand that yet. Whoops. Thanks, I'm glad you like it. I've been talking for a long time, so I think I'm going to sign off now, and I might play video games for an hour. We'll see how that goes. How do you handle GL get error? Well, right now you just call GL get error, just like before. Like, I don't like the way GL get error works, but it's the OpenGL API, right? So I'm not trying to change the way things work for APIs that already exist, but if you're making a new API, we can make it, encourage better things. Like for GL get error, you could put a hashtag must in front of the return value. That'll link just fine because it doesn't change the calling convention at all. It's just, why would you call GL get error if you're not paying attention to the return value, right? Have I considered creating an online redevel print loop? No, I don't think redevel print loops are any good. Compiler size. Probably about the same as last time I tweeted, a little bit bigger. Unless I have some junk files in the folder. 39652 lines. Thanks, Joe Sweeney. Yeah, it makes me excited to program too. Compiler binary size. I don't know. We're not exactly. Wait, where is it? x64 release. 14 megs, which seems really large, but I guess that's. We're not optimizing for size, certainly. And I guess that's what x64 binaries look like these days. It's only a 40,000 line program. I don't know, man. Maybe something dumb is happening there. Will the compiler ship as a statically linked single library binary? Probably, yeah. I mean, we may give source code to people as well, but we're not going to require people to compile it. Unless you're on one of those operating systems where shipping a binary sucks, then maybe we'll have you compile it, but eh. How's the tag union thing going? I decided not to do it for now because it didn't cover enough of my use cases. I actually was going to talk about that during this demo, but I didn't, so. So no plan for tagged unions in the near future, but we may do them eventually. Yes, there are plans for inline assembly. It's not going to happen for a little bit because writing an assembler is a pain in the butt. The status of the SOA replacement is not yet. It's working. It's waiting on a big feature that has to go in first. So not for a while. If we don't ever do that, there's a fallback where we re-implement SOA kind of in the old way but different. So we'll see. How hard would it be for someone to write their own implementation? I don't know. I mean, there are people who have done things that are similar but maybe don't have all the features and made different choices. So like Ginger Bill has a language called Odin that I think is inspired by this, but he has different opinions about what's important, and so it goes in a little bit of a different direction. I don't know. I mean, you can judge by the features how hard you think it is to implement this, and then of course keep in mind it's probably at least 5 times as hard as you thought, because that's how programming is. I don't want to keep talking about SOA because I've said it like 5 times on streams. Do we support dynamic libraries? Yes. Can you reload it at runtime? Well, I mean, that's an operating system feature, right? If you mean can you do edit and continue, we don't do that yet, but we probably will, yes, by compiling to dynamic libraries and reloading those. It's just we haven't done that yet because compile time is so fast that you don't save much by doing that. You save the setup of your program state or whatever, but you don't really save much. If someone wanted to do tag unions, could they do it without metaprogramming? I don't know. Possibly. You'd have to think about it or experiment in some way. Like with a run directive, you definitely could do it. It's just you'd have to type #run somewhere. Once we have macros, then that could be hidden from you, and maybe it would be kind of reasonable. Tim, are you trolling me with the self-hosting question? Compile time type tags for thread ownership would be helpful while still letting programs do whatever they want. Unclear on what form that would take. Yeah. What's the status on having a searchable FAQ? I don't know. We'll do it sometime. We don't have anything yet. Will there be async? Probably not. That's more like a library thing than a compiler built-in thing. All right, I'm going to stop the stream. Thanks, everybody. I have tickets for a movie tonight, but I might do about an hour of gaming first, so I might restart the stream in 5 minutes. Thanks for coming by. If you missed any of this, it'll be on YouTube pretty soon, like tomorrow.